Welcome back, engineers. Let's take a look at another problem. We're going to work this in Excel as well as on Word here. Let's assume for a second you guys are out creating new elements and you've come up with something pretty exciting, and so you name it after yours truly. So you've created this element called marquardium, and this is a phase diagram for marquardium. So you'll see we have pressure along the x-axis, and along the y-axis we have temperature. Pressure is measured in gigapascals and temperature is measured in Kelvin. If the temperature is below 600 Kelvin, then marquardium is in a solid phase. But if it's above 600 Kelvin, then the phase depends on the temperature as well. And so there's this linear line right here that separates the gas from the liquid. If it's below that line, it's the liquid phase. If it's above the line, it's a gas phase. So we need to know the equation of that line for starters. So what we'll do is we'll look at this point right here that has a pressure of 5 gigapascals and a temperature of 600 Kelvin. And then up here we have a pressure of 25 gigapascals and a temperature of 1800 Kelvin. So if I go to look at the slope of that line, rise over run, my rise is 1200 Kelvin. And my run is 20 gigapascals, and so that's a slope of 60 kelvins per gigapascal. And then if I plug that into an equation to figure out what's the equation of that line, if you will, I will find out that the equation of this line is the temperature equals 60 times the pressure plus 300. Right, so if we can follow this line down, it would intersect, the y-intercept would be right down there at 300 when the pressure is equal to 0. But we did the calculations off screen, if you will, so that should be the equation of that line. All right, so now let's take a look at the spreadsheet we got put together. And I want to do a couple of different things on his spreadsheet. First off, let's start in the upper left. I've got the maximum temperature for a solid. You'll notice this takes up 3 cells. So what I'd like to do is just kind of combine all those cells. So I highlight all 3 of these cells, and then I hit merge and center. And you can see the whole thing now is really one big cell. And that's just a formatting sort of ordeal there, but it can make things a little easier. And just because we can, let's go ahead and fill this cell in, and we'll make that orange. All right, that kind of just gives a little bit of color. And then over here, the maximum temperature for a solid, and this goes back to the Word document here, right? The maximum temperature for the solid is 600 Kelvin. And I've put that 600 over here. When I type in a number, it gets right justified. And when I type in letters, I get left justified. So over in this cell, I've placed the temperature scale, which is Kelvin. And then they're together. I left them left and right justified. I could make them like centered. I could center both of them, but I just don't think that looks as good. So I'm going to undo that. So we'll leave them that way. And let's go ahead and put those in brown as well. All right, then I used a random number generator and created some pressures that you'll see in this column and some temperatures that you'll see in this column. So I'm going to do something just a little different here for that cell. Let's go ahead and use something a little more yellow. And then the temperature between gas and liquid, that's going to be based on this line. So when I look at the pressures and the temperatures I've got, I need to determine what the phase is. That's the assignment here, if you will. I want to know what's the phase in given the temperature and the pressure. Well, if the pressure is below 600, it doesn't matter what the temperature is, that's going to be solid. But if the temperature is above 600, then it's going to depend on, is it below this line or above that line? So this line determines the temperature. Above that temperature, it's gas. Below that temperature, it's liquid. But I need to know what the pressure is in order to figure out what the temperature is on that line. So that's why we create this specific column here. That's the temperature based on pressure between gas and liquid. All right, so we're going to highlight that a little bit differently than we did the previous one. And then in the end, what I want is the phase. Okay, so let's start with the temperature between the gas and the liquid. And this goes back to the line itself. So the temperature is equal to 60 times the pressure plus 300. So on the spreadsheet, I'm going to put equal to 60 times the pressure, but the pressure is here in column A, plus, I think that was 600. Let me just check. Nope, it's 300. So glad I checked. Plus 300. And so there's the line, the value of the temperature with a pressure of 9 gigapascals. All right, and I want to copy that down, and I have one cell reference here. Let me double click that. The A4, that's the pressure, so I want to copy that. I want that to change as I copy down. So I'm going to grab the lower right hand corner, and I'm going to pull that down, and there we go. And you can see the the 810 here for a pressure of 9 gigapascals and the 828 for a pressure of 9 gigapascals. The reason that those are different is because this isn't really 9, it's 8.507, you can see that. And that's not really 9 here, it's 8.8. So there's a slight variation in there because, again, remember what I've done here is I used a random number generator, and then I formatted them so that there's 0 decimal places. Just makes my life simple. Maybe it would be easier if I go one more decimal place just to kind of play with that a little bit. As a matter of fact, here, let me reduce the number of decimal places there because that's just too many. And we'll leave it there. All right, now the phase. How do I determine the phase? So here's where we're going to get into if statements. So I start off with an equal sign, and I'm going to type if. Okay, and let's just take a look at this. Checks whether a condition is met and returns one value if true and another value if false. So we want to start off with, going back to document, the pressure, not the pressure, the temperature. If the temperature is below 600, it's a solid. So I'm going to say if, open parentheses, the temperature is less than, I'm going to put less than or equal to, I'm going to say that if the temperature is 600, then it's going to be a solid. 600, then it's a solid. So I'm going to just put solid. I'm putting it because I'm returning a word, so I'm just going to put it into double quotes. And then I'm just going to say other. And then we'll come back to this in just a second. So that one is solid because the temperature is below 600. Let's copy that down. And you can see this one is below 600. This one is below 600. These two are below 600. Everything else is above 600. So everything else is other. All right, so I'm interested in other. What am I going to put in there? All right, so double click in there. So now in here where I had other, I'm going to put another if statement. And the if statement will be if the temperature is above the line. So if T, the temperature, is greater than this value, which is the temperature for the pressure given, then it's a gas. If it's above the line, it's a gas. And if it's below the line or on the line, it's a liquid. Close that parentheses. You notice the black one is filled in, and I should be good to go. Too many parentheses. So I'll accept the correction, and then we'll pull this down again. And those solids should remain solid. They're still solids. And then I can see liquids and gases in here. So it looks like I got it right. Looks like I got it right. We'll come back to this in another video. If you have any questions on this, please let me know in the comments below.